Hey, I'm Noah.
I'm Isaac.
And I'm Michael. This is our data set.
Woo, data set.
We decided to choose the AdHealth data set, which is a data set that is following a group of individuals throughout their lives, asking them several different questions of several different variables, and they go through about every 10 years. We were going through the first wave, the youngest wave generation, and we decided to go through their specific variable questions are about academics and about suicide. We wanted to see if there was any correlations and relationships between the two, and we wanted to discover if there was anything that we could glean as Truman students from this data. We also found a data set in this, a variable set in this called attractiveness, about how interviewers saw their attractiveness of their interviewees, and we wanted to use the halo effect and see if more attractive students had a higher likelihood of having higher standards and opinions of academics in their future than those who did not. We used this and we plastered our sources on this main page. We want to show you the relationships that we had gleaned.
So here you can see this is the AdHealth codebook. On the right, it gives you the variables, and some of the names are like H1GH15. They're a little hard to remember what they go along with, but here are the questions that they go along with. So we took the data set and we put it into RStudio. And here you can see that we use the rename command to change the variables for the names that they were given to the names that we wanted. And then we use the select command to select the certain variables that we wanted to use. And then we imported it back into Excel. And now that it's in Excel, we created a data dictionary so you can understand what the spreadsheet means better. And as you can see, that some of the variables are on a 1 to 5 scale, 1 being the worst, 5 being the greatest, and the race variable, just a number for each country. That's all.
Alright, so I'm here to talk about what we did with our data for the end product. First, in our final R document, we use setSeed so that it's reproducible in case anybody else wants to check our results. Then we do a little bit more with cleaning our data set. We omit any rows with empty values, reduce their number of attempts to whether or not they attempted, and then we drop our column number, the number of attempts, and if there are any injuries from their attempts, and we turn them all into factors. Feed that to our tuneRF command, which tunes the random forest to find the best possible value for mtry. So then we create a random forest that seeks to predict whether or not they attempted suicide from all the other variables with an mtry value of 2. And then we create predictions from it using the trained data set. And so down here you can see how important our random forest rates some of the variables. Unsurprisingly, suicidal thoughts are the most important variable in predicting whether or not someone attempts suicide. 2 other variables that were deemed important are whether or not they had caring adults in their life, which is pretty common sense, and whether or not anyone in their family committed suicide. That's also not very surprising. And then here we use our validation set to estimate the amount of error in our predictions. So here we end up with about a 3% error rate, which sounds pretty good. But when we then use a confusion matrix, which is a metric in machine learning and data science, that shows you how many false positives, false negatives, true positives, and true negatives you have so you can get a better idea, we see that although our model correctly predicts that people did not attempt suicide 1,009 times, while never predicting that they did attempt suicide when they did not, it also mislabels 30 out of 31 people who attempted suicide in our validation set. So while it has over a 97% accuracy, if we just go by accuracy, we can see the smaller group in our data set is left by the wayside when they're the group that is more important to predict. Here we can see that in our full data set, out of all the people, about 6,300 did not attempt suicide, and only 230 people did attempt suicide. So obviously there's a very large difference between the sizes of each category. So our algorithm, it seems, noticed that and decided to err on the side predicting that they did not attempt suicide, which is not very useful information for us. So here we use oversample to oversample the minority category in this data set, in this case people who have attempted suicide, in order to give us a lot more data points so that our algorithm cannot focus on the majority data set. So then we create a model from that with the same parameters, and we create our predictions, and we look at the importance of variables. So here we can see suicidal thoughts are still very important in predicting. Whether or not any friends committed suicide is also important. Caring adults is still important, and whether or not friends attempted. Down here, we try our accuracy with the validation data set, and you can see our error has gone up quite a bit. It's now sitting at nearly 8% instead of 3%. And on one hand, that's not good. But if we look at the confusion matrix again, we can see now we correctly label the majority of people who do attempt suicide, although there are almost 80 false positives now. But in this case, a false negative means someone could die. A false positive means someone has to go through an awkward conversation. So that is the way we want our model to err. And then here we use dimensionality reduction to take all those variables we're using and squish them into just an XY plane so that we can try and visualize our data and see if we can find a pattern in it. So this first graph right here will graph orange are people who did not attempt suicide, and light blue is people who did attempt suicide. And this is using the PCA method of dimensionality reduction. And then down here a little bit, we have one that orange is our model predicted they did not attempt suicide. Blue is we predicted that they did attempt suicide. So you can see there's more blue dots now, but they're in the same general area and share a pretty similar pattern. And right below that, we do the same basic thing, but with a different method called TSNE. So here we can see there's a couple of sporadic dots. It's hard to pick out a very good pattern though. And down here we can see our model also got in the same general areas, although again, there are more false positives. And then finally, we have the confusion matrix based on the test set. This will give us as close as we can get to an accurate prediction of how our model will do. So we can see that overall we had nearly a 92% accuracy. We had about 90 false positives, about 7 false negatives, and about 30 true positives. And then there were over 1,000 people who did not attempt suicide and who were not labeled as attempting suicide. So, although our accuracy has fallen, we are now a lot better at pinpointing who attempts suicide.